Okay, today we're going to be talking on atomic orbital and hybrid atomic orbital. Okay, first of all, atomic orbital. Now we all know that there are four types of atomic orbitals. They include the s orbital, the p orbital, the d orbital, and the f orbital. For our scope now, let's just cancel this immediately. I'm not going to be talking about it. Also, the d orbital, we won't talk about it, but let me just give you like a bit on the d orbital. Okay, the s orbital. Let's start with it. There are only one type of s orbital. Keep that in mind. I call it the s orbital. You can call it whatever you want. There are three types of p orbital. Now, no jokes for the p orbital. You have to call it the name I actually call it now, because this is actually the official name. There are three types of p orbital depending on their orientation. There's the px orbital, the py orbital, and the pz orbital. Now, there are five types of d orbital. This is like the only part I'm actually going to talk about the d orbital for, because we all know we are dealing with carbon, and carbon doesn't actually deal with d orbital. Look at the electronic configuration of carbon. You won't see anything relating to d orbital. So now, there are five types of d orbital. There is the dxy orbital, the dxz orbital, the dyz orbital, the dx squared minus y squared orbital, and the dz squared orbital. Okay, I hope you got all of this. Now, let's start with our s orbital, the s orbital. I'm going to be telling you, like, this is not suborbital, if I make a mistake now. Okay, the s orbital. Now, I'll be telling you characteristics of the s orbital at first now. Now, the first characteristic I want you to know about s orbital is that it is spherical in shape. The orientation is spherical. So let me just put spherical shape here. Now, the second characteristic I actually want you to know about is that this s orbital has the lowest energy. Like, whenever you're drawing like your atomic structure, after you're done drawing the nucleus as a dense structure, dense middle, the first orbital that has the lowest energy, that only carry like a maximum of 2 electrons, that's the s orbital that I'm actually describing to you now, and it has the lowest energy. So now my second characteristic now is it has the lowest energy. I'm going to be giving you 3 characteristics now. Let me just make it 4. Okay. The third one, there are only one type of s orbital. I've said it before. That is like the s orbital, the s type orbital, if I put it that way. That's the only type of s orbital. Now, okay, there's only one type. Okay, and the fourth one, it can carry a maximum of how many electrons? It can carry a maximum electron equals to like I said before, we're going to be talking, like I gave the orientation. Now this part now, this is like the orientation. This was what I was talking about. I want to draw like the s orbital for you so you can actually look at it, see its orientation on the xy axis and every single thing about it. Okay, now let me draw the s orbital. Now this is my xy axis, this is my y plane, this is my x plane. Now, if let me include z, because I'm actually going to be talking about z now. This is my z plane. My z is meant to actually be bulging out of my book, because actually like taking the entire structure to a 3D like structure. But since I'm unable to like make it bulge out or come out from the book, I won't be able to like represent z. So like this is the satisfactory way I can represent z. Okay, let's continue. Now, I said before that the S orbital, the S orbital is spherical in shape. So now let me just draw it. It's spherical. Oh, it's so big. Okay, you can go down. It's spherical in shape. Now this is the sphere. Now I said that the nucleus is located at the center. Like, just imagine your atomic structure. Let me draw a little one beside it. Now this is where the nucleus is. This is where the S orbital is. If you just notice, we're just putting like a plane here. I'll actually just like seeing the orientation. Now it's spherical in shape, and this is where the nucleus is located. Yeah. So let me write nucleus location. Nucleus location. And the electron is now located in this sphere. Let me just put it around this sphere. So this part, actually, they're in orbit. We all know that about electrons. Electron location. Like I said before, they carry a maximum of 2 electrons. 2 electrons. Did you get that? Okay, I'm sure you've gotten that. They carry a maximum of 2 electrons. That's very important whenever you're drawing the electronic configuration of any compound or any element at all. If you forget to put the 2 electrons in the s orbital, you end up making a big mistake, and that's how you fail it. You just fail it immediately. Okay. Now, I'm going to my p orbital. Let's describe the p orbital. The p orbital, I need to be putting a hyphen or whatever. Now, like I said before, let me write the characteristics. Now, the first thing about this is the shape. It is dumbbell in shape. Dumbbell-like in shape. Dumbbell in shape. That's like an 8. Okay. Oh, wow. I'm so good at drawing. Wow. Congratulations to my art teacher. Okay. This is actually my dumbbell shape. Okay, the next thing I said, it has a higher energy like level. It's higher in the energy level. Let me just put it, the energy ranks is like higher to the s orbital. It's next to the s orbital. After it, you can see the d orbital, then you can see the f, then that's how it goes. It's higher than the s orbital, so I can just put my second characteristics to be higher in energy level than s. In energy level than s orbital. Now my third characteristic that I'm actually going to put out here is now, okay, we've talked about the higher energy level and we've talked about the shape. Now I said before, there are three types of p orbitals. Now the s orbital, just say there's only one type. Now the p, there are 3 types. There are 3 types of p orbitals. There are 3 types, and we're going to talk about them in a minute or two. And the 4th type is that it carries a maximum max electron. Max electron is 6. Okay, now we've talked about the max electron and everything. Now let's talk about the types of p orbitals. Like I said before, there are 3 types. I've given you the list before. So px orbital, py orbital, and pz orbital. I'm going to actually draw the orientation of all these orbitals, so don't worry, we're getting there. Now the px orbital, why called px? Why called py? Why called pz? You can actually pause the video and give a guess, but let me just continue. If you want to pause, you're free to pause, then you can continue. That's okay. Now the px orbital, it is actually called the px orbital because of the orientation. Like I said, we're getting there. The orientation of the px orbital, it lies on the x-plane. That's the reason why it's called a px orbital. It's because of the plane it lies on the x-plane. The py orbital, same thing, it lies on the y-plane. The pz, same thing, it lies on the z-plane. I told you that, like, now this is my atom. Let me just put it here. This is my nucleus. Like, this is my s orbital. This is my p orbital. Now the orientations on these p orbitals, this is like what I'm actually going to talk about, whether it's on the X plane, on the Y plane, or on the Z plane. Okay, now let me remove this structure. Okay, now there's something you need to know about all these PX, PY, and PZ orbitals. Like, the first thing I want to tell you is that they each carry a maximum of 2 electrons. You'll be wondering, because I say the p orbital carry a maximum of 6 electrons and I'm putting 2 here. It's just mathematics. 2 electrons. Now, because all these p orbitals can all be referred to as p, all the p, the px, the py, the pz, they can all be commonly called p orbitals. So we can see they carry a maximum of 2 plus 2 plus 2, and that will give us 6 electrons. 6 electrons. 6 electrons. 6 electrons. So we can see that they each carry 2 electrons, but when you combine all of them, they each carry like 6 electrons. So that's like, if I put it, that's all about the p orbital for now. Now let me start drawing the orientation before I forget to draw it. Now, the orientation of the p orbital. I said there are 3 types: the px, the py, the pz, and I've already showed you why they are px, py, pz. Let me try and squeeze some of them here. If I put this to be my px, okay, py, okay, and pz. Like I said before, this is not hard at all. Now, it's dumbbell in shape, so if I call this the px, the py, and the pz, the representation of this, I'm actually going to draw like a dumbbell shape in all the plane. This is the x plane, x, y, z. Let me put the z plane for all, or let me not write it so it doesn't like, okay, z. This is the z plane. Now look, it's lying on the x plane, so I need to just draw an x dumbbell shape. This is where the electrons are actually located, yeah, and this is actually the nucleus. This is actually the nucleus. Let me draw that line again. This is nucleus location, nucleus location, and this is electron location. This two parts actually, electron location, electron location. Okay, I hope you've seen that. Now let me erase it. Okay, okay. Now that same thing, but now for the py orbital, we're going to be drawing it on the y plane, the dumbbell on the y plane. Okay, the dumbbell is on the y plane. This is the nucleus location, same thing, and this are the electron location. Now, electron location, nucleus location. Now, the pz orbital on the z plane. Now, in some books, actually, you will actually see them representing this as minus and plus, this as plus, minus, and this as minus and plus. Do not actually be scared and be saying like this electron has a negative and positive charge. No, they are just trying to like actually represent the planes and everything. That this is on the negative plane and this is on the positive plane. Okay, now I'm done talking about the p, x, and all the orbitals short, because I'm not going to talk about the p and the d orbital. So let's continue with our structure. Now we're going deep into carbon. I'm going to talk about the electronic configuration of carbon, then I'm actually going to end this. Now, the electronic configuration of carbon. We all know that carbon has 6 electrons. So we've all seen this before. One S2, two S2, 2p2. Now this is the ground state of carbon. This is what we are all meant to draw whenever they ask us to draw the electronic configuration of carbon. But now there's something that I need to tell you. Carbon, carbon is mostly non-reactive in this state. If we carbon mostly form tetrahedral compounds. That is, it mostly combines with 4 other elements to form a compound. But there are only 2 lone pairs of electrons. Where is it going to combine with? This was a struggle before, when we're still trying to understand carbon. But then we later found out that carbon does not react in this stage. It reacts in the excited state, and in the excited state it has 4 lone pairs of electrons. I'll show you how all this happens. Now see, let me go back to the ground state. C6. This is the ground state. Okay, this is the ground state. 1, 2, 1, 2. We all know this. 1s2, 2s2, 2p2. Now this is actually the ground state of carbon. But in the excited state, this is what I'm actually going to talk about. Excited state. The excited state, what actually happens is that one carbon, now all these are called spins. All these lines I'm actually drawing like this, they are called spins. This is what they call them. Now in the excited state, this down spin in the 2s2 carbon actually moves to the 2pz. Now look at it. This is 2px. Let me put it downward. 2px, 2py, and 2pz. So they actually one of these actually moves to the 2pz. You see that the 2pz is actually empty shell, and according to our rule, I think it's Hund's rule, it has to pair singly, electrons have to enter the orbital singly before pairing occurs, if I'm not mistaken. Yeah, so we can continue with that. So now see, this actually moves and it fills in the 2pz electron, thereby giving us a carbon. It's still C6, but instead of it to have this 2p2, you see the funny thing about carbon. This is one of the unique. Carbon have unique properties. I might talk about that later in a while, but let's continue with this. So now this will have a lone pair. This will have a lone pair, and a lone pair. This is 1s2, 2s1, 2px1, 2py1, 2pz1. Now if you look at this, 4 electrons can actually enter now. How funny. And the electron can actually come here, come here, come here, and come here, giving carbon what? It's now it can actually form a tetravalent molecule, and this is where carbon normally combines in, not in the normal 2p. Now if you want to actually write the electronic configuration without using this diagrammatical method, you actually want to just write it down. Now take note of this. If they tell you to actually write the ground state of carbon, if they tell you to just write, or let me just say the electronic configuration of carbon, please write this: 1s2, 2s2, and 2p2. This is actually what they want you to write. But they will specify when they say write the excited state of carbon. Then if you write this, you end up failing it. The excited state of carbon, is actually 1s2, 2s2. Eraser. Okay. 1s2, 2s1, and 2p. If I put it, let me just break it down: 2px1, 2py1, and 2pz1. If you want to collapse it, you still have 1s2, 2s1, and 2p3. Get it now? Okay, this is actually where I'm going to be ending my video. Thank you. You can actually like and subscribe. Thank you for watching.